We're developing sensors to help us monitor the structural integrity of new space structures. It's important because we need to ensure the structural integrity of inflatable habitats in the ISS to ensure that the astronauts and people are safe within them. For inflatable habitats, leaks can cause a loss of pressure, and then you have this habitat that is expanded in orbit to be a larger volume than when it's shipped or when it's flown into space. So if you lose pressure due to a leak, it can collapse, and that can be, very, very bad because it can cause people to be trapped within the structure, or it can cause the structure not to be able to be used anymore. You can't have a leak because you lose oxygen. You only have a finite amount of oxygen. The sensors that we're developing will detect impacts due to micrometeorites and orbital debris striking the structure, and also detect the vibration caused by leaks as air leaves the structure. So we started with existing designs that were created by previous researchers that were building these carbon nanotube sensors for strain measurement, for load measurement, and we adapted that design for the acoustic sensing. And we built the test setup for where we can generate ultrasound within an aluminum block, and then we try to measure the vibration with the sensor on the other side. We learned that the physical properties of nanotubes varies greatly from specific nanotube to nanotube, and that in order to be able to detect the acoustic waves, we'll need to be able to select which tube we want to build our sensor out of. We've got a few candidates for what tubes to use, but we need to find a source or a technique to separate tubes into the exact species that we want.